The osmotic pressure is another colligative property, the last one out of the 4 that the last one, the 3 have been discussed in the earlier classes. Now, the 4th one, that is osmotic pressure, which is another colligative property. To know what is osmotic pressure, first we should know the process of osmosis. What is osmosis? Osmosis is actually the phenomena which normally we observe, and in lower classes everyone must have studied in biology, as the plants will take water through roots, and the process is what we call osmosis. So, the term osmosis must have been known to everyone from the biology in lower classes. What is actually that? What happens? How plants take water from earth through roots by process of osmosis. Osmosis is a process in which solvent moves from pure solvent or low concentrated solution to solution of high concentration. From pure solvent to solution through a semi permeable membrane. Osmosis is a process in which solvent moves from pure solvent or lower concentrated solution side to a solution of higher concentration through a semi permeable membrane. Means, suppose if you have a huge tank which is divided into 2 parts by keeping a membrane say in between. This is your semi permeable membrane. On one side you filled the tank with a pure solvent, and on the other side let us take some solution in which say some non-volatile solute like sodium chloride is added, side A and side B. Solvent is present in side A, solution of a non-volatile solute something like sodium chloride is present on the side B. Now, what happens is that the solvent starts moving from solvent side to the solution side. So, as a result what will happen is that the amount of solvent on the side A decreases and in side B it increases. Now, the question is, first of all, what is the reason that solvent moves from side A to side B? Point number 1. Point number 2, how long this transfer takes place? Will it takes place continuously till the whole solvent from side A get transferred into side B, or only to certain extent, or after some time is it possible to transfer solvent from B to A? What is the situation and what is the main reason, and why not it cannot take place from B to A? These are the things that first we should try to understand. For that, the basic reason to know is that reason for solvent to transfer from solvent side to solution side is that on the principle of vapor pressure, we can easily explain this. Vapor pressure on side A is say P naught, side B is Ps, because this is pure solvent and this is solution. Vapor pressure of solution is less than the vapor pressure of the pure solvent, which already we have discussed it. So, here Ps is less than P naught and Ps is less than P naught. So, obviously, there is a pressure difference. Due to the pressure difference, the solvent from the high pressure region, that is solvent side, will be pushed towards the low pressure. As you know, the process of diffusion, already in the gaseous state we discussed, and we know that process of diffusion takes place from a high pressure region to low pressure region in gases. Now, this is also somewhat similar to that situation, where here you have the vapors of only solvent here, and here also you will have the vapors, and these vapors will exert more pressure on the solvent side, these vapors will exert lower pressure. So, due to this high pressure on the solvent side, this is pushed towards the solvent, I mean towards the solution, due to the pressure difference. So, first of all, direction of passage is A to B, because P naught is greater than Ps, and how long it keeps taking place? Till pressure on both sides become equal. Pressure on both sides become equal. Till then, the passage of solvent will be taking place. If once equilibrium is reached, then the solvent either moving from A to B or B to A does not make any difference, as the pressures becomes equal at that equilibrium state. That state is what we call equilibrium state. Now, what is the purpose of using the semi permeable membrane? The selection of the semi permeable membrane should be such that it allows passage of only solvent through it, but not solute. The selection of the semi permeable membrane should be such that the pore size of the membrane should be such that here you will have pores, that is the reason, and the pore size is not too large, not too small, that is the reason we call it as semi permeable. The reason we call it as semi permeable means neither it completely prevents the flow, nor it will allow completely the whole solution to flow. It allows only the solvent to pass through it. That is the reason we call it as semi permeable membrane. The selection of the membrane should be such that it should allow passage of only solvent through it, but not solute. Then here, what are the different types of membranes that we use? For this purpose, we have different types of membranes. Some of them are natural membranes, some of them are artificially prepared. What are these artificially, which are the ones that are naturally available and which are the ones that are artificially prepared? Now, we see. So, now the semi permeable membranes, the natural semi permeable membranes are, one is the pig bladder, which is most commonly used. Second one is skin of vegetables like potato, onion, etc., and the cell walls in the human body. Then white of the egg. These are all the semi-permeable membranes that are naturally available, and artificial ones include, depending on the pore size that is required, the artificial membranes also cellulose on wire gauze or coating a substance with a solution of cupric ferrocyanide. These are artificial membranes. So, as I told, now cell walls is active, cell walls will act as membranes. So, is the reason that blood, the flow from outside environment to into the cell or from cell into the outside environment, that exchange will be keep taking place, right. So, these are all the natural and artificial membranes. Now, what is the mathematical equation we use to determine the osmotic pressure of any particular solution or any particular solvent or in general a liquid? What is the governing mathematical equation? The mathematical equation is that osmotic pressure is represented with the symbol pi. We write that similar to ideal gas equation, that is P v equal to nRT, or we write P is equal to n by V RT, or this P is equal to n by V is nothing but molar concentration CRT. Exactly same way, now osmotic pressure pi is equal to CST, pi equals to CST. This pi is equal to CST, this pi is osmotic pressure of the system, C is of course molar concentration of the solution, molar concentration of solution, S is solution constant, is what we call solution constant, which is identical to gas constant, R whose value is equal to 0.0821 liter atmosphere per mole per Kelvin. T is of course temperature in Kelvin scale at which the process of osmosis is being carried out. So, the equation is very simple, just the ideal gas equation, P v equal to nRT, same thing we use this also, P is equal to CST, C is the molar concentration, S is the solution constant here we call, but for all practical purposes that S is same as the gas constant R with the value of 0.0821 liter atmosphere per mole per Kelvin. T is of course the temperature, right. So, this osmotic pressure, from this equation it is very clearly that you can understand that the osmotic pressure of a solution is dependent on molar concentration of that solution. Osmotic pressure of the solution is dependent on molar concentration of the solution. So, that means osmotic pressure is a property dependent on concentration of the solution. So, is the reason that this is again a colligative property. So, the osmotic pressure pi is equal to CST, right. Now, for two solutions, if two solutions irrespective of whatever the solute it is, irrespective of the nature of the solute, if two solutions have same concentration, that is C1 is equal to C2 at same temperature, obviously they also will have same osmotic pressure. Two solutions with same molar concentrations. Two solutions with same molar concentrations also will have same osmotic pressure irrespective of the nature of the solute, whatever may be the solute it is, because the colligative property, as already we told, it depends only on the concentration. So, as the concentration is same, osmotic pressure is also same. Such solutions are what we call isotonic solutions. Two solutions with same osmotic pressure is what we call isotonic solution. So, the next is, that means if two solutions are having different osmotic pressure, if you have different osmotic pressure, then the solution with lower osmotic pressure is called hypotonic, and the solution with higher osmotic pressure is called hypertonic. Solution with lower osmotic pressure is called hypertonic, and solution with higher osmotic pressure is called hypertonic. Now, what is the use of the process of this osmosis? The process of osmosis is that suppose if you take a cell wall, where blood flows, if this is kept in a pure solvent water, this is a cell wall, blood cell, this is a blood cell, in which this is in case 1 it is pure solvent. Now, blood cell now being a concentrated solution compared to the solvent, what will happen is that now this being the solvent side and this being the solution side, solvent flows into the blood vessel, and when blood cell, when kept in a pure solvent, that is water, cell volume increases, and also cell may also burst. But if blood cell is kept in a solution of 0.1 molar NaCl, now that being more concentrated, blood flows from cell into solution. As a result, the cell shrinks. Cell will shrink. As a result, when the cell shrinks, the flow in the blood, the flow of the blood, the vessel, the rate of flow decreases because it gets shrinked. That again, that is the reason that, where the blood circulation, blood flow will get reduced, and possibility of heart attacks and all. So, is the reason, in fact, that is the reason that we are always advised not to take too much of salt in our food, because that shrinks the blood cells and it will increase the pressure. That is what we call blood pressure. Blood pressure will get increased. So, is the reason one has to reduce the salt content in the food, right. So, this is the main application, and like this we can say many more. Even in the case of plants, already we told that they will take water through roots by the process of this osmosis. And you can take another general example. If you take an egg and placed it in a water, after some time the egg will expand. The reason being that water flows inside through the white of the egg, and if the same egg, if you place it in 0.1 mole sodium chloride solution, then the what you call it will get shrinked, as the solution is now being more concentrated than the liquid in the egg. So, like this we have many general day to day applications by process of this osmosis. As we have different applications of osmosis, also we have another process called reverse osmosis. The basic principle, whether it is osmosis or reverse osmosis, as already that we have discussed, the basic principle is difference in pressure. In the case of osmosis, we told that it is the difference in the vapor pressures that makes the passage of solvent from solvent side to the solution side. Now we discuss about the next, the concept of reverse osmosis. Okay. Now, the reverse osmosis. The reverse osmosis is, as the name itself indicates, that it is opposite of osmosis. In the case of osmosis, what we told is, when you have a tank in which it is divided into say two parts with by keeping a dividing membrane, that is what we call semi permeable membrane, and on one side if you take a solvent, that is side A, and solution on side B, where this pressure is P naught and P s. Already we told that P s is P naught is greater than P s, and osmotic pressure is what is defined as P naught minus P s, because osmotic pressure is defined as the excess hydrostatic pressure required to apply on solution side, so that the process of osmosis is prevented. Osmotic pressure is the excess hydrostatic pressure required to apply on solution side, so that the process of osmosis is prevented. Because when the pressures on both sides become equal, obviously there is no chance of solvent to move from either from side A to side B or side B to side A. There is no chance. So, whatever the difference is there, this is nothing but what we call it as osmotic pressure. Now, what is reverse osmosis? So, in the process of osmosis, this is the direction, this is osmosis. Reverse osmosis is, obviously, if we observe the passage of solvent from solution side to solvent side. So, it is passage of solvent from solution to pure solvent. So, this is osmosis A to B, B to A is reverse osmosis. That means the direction of flow is reversed. That is the reason we call it as reverse osmosis. When the osmosis will happen, already we told, when there is a pressure difference between A and B, solvent and solution. If you take two identical concentrations of solutions, there is no osmosis, their osmotic pressures will be equal, right. But then when do we have this reverse osmosis? When it is possible? It is possible if excess hydrostatic pressure is applied on solution side, excess hydrostatic pressure is applied on solution side. How much excess? that the pressure applied is more than the vapor pressure of pure solvent, that is P naught. Then solvent starts passing from solution to pure solvent. So, what happens if the pressure what you are applying, if this is exactly equal to whatever the difference it has with the P naught, that we are calling it as osmotic pressure, P naught minus Ps. Then in that case what is happening is the flow of solvent is not taking place either from the side A to side B or from side B to side A. But instead if you apply excess hydrostatic pressure, how much excess? That it should be greater than the P naught, the vapor pressure of the pure solvent. So, as a result what will happen? The pressure is so high that it will allow the solvent to move in this direction, and the pressure is, in certain cases what will happen is that the pressure is so increased that by keep on increasing the pressure on side B, by keep on increasing the pressure on side B, what we can achieve? That solute can be separated from solution. What is happening? When you keep on increasing the pressure, first of all what we are doing? We are increasing the pressure. How much we are increasing? We are increasing such that the pressure on side B is more than the vapor pressure of pure solvent A. So, what happens? The solvent will move from side B to side A, and if you keep on increasing the pressure, what will happen? The whole solvent will move from side B to side A. Finally, you will reach a stage where all the solute particles will remain in the solution side B, whole solvent get transferred into the side A. So, what you are doing? By the process of reverse osmosis, you are able to separate out solute and solvent from a solution. This is a very important point. Okay? I will elaborate it in more details. So, here what is happening in reverse osmosis? By keep on increasing the pressure on solution side, the whole solvent from solution will transfer into the other side. Therefore, on solution side only solute will remain. So, finally, what we are doing? We are able to separate, we can separate solute and solvent in a solution. So, by process of RO, reverse osmosis, RO, we can separate solute and solvent in a solution. This is a very important technique. Reverse osmosis is a very important technique which we use in our daily life. that in the purification of water, water purification, this plays a very important role nowadays. The borewell water, the hard water can be converted into drinking water, because on one side of the tank you will take the bore water, on the other side you will take pure water. Then with the help of a pump you will keep on increasing the hydrostatic pressure. With the help of a motor you will increase the hydrostatic pressure, so that the salts will remain on one side of the membrane and the whole pure water will go on to the other side. So we get a very pure, good drinking water. So this is a technique what we use for converting borewell water, well water, salt water, hard water into a normal drinking water. This is the most advanced technique what we are using in the RO filters. Even in the normal advertisement you can see that RO system to purify the water. So this is a technique what we use.